At Alteva, we are driving Europe's battery independence. So our current supply chain is pretty complicated, as Kalle just pointed out. However, the gist is there is one major player that dominates the entire battery value chain. Not only does China dominate cell production, but also cathodes, anodes, separators, electrolytes. So anything that goes into a battery is dominated by a single player. And even if we go ahead in Europe and we build more cell production capabilities, we are still very much dependent on the supply chain coming out of China, which is a non-allied nation. And we can do something about that. We're actually developing technology that has been researched at the German Aerospace Center for more than 15 years now, which allows us to break this dependency. And we're developing lithium-sulfur batteries. So we're using two active materials, lithium and sulfur, that are abundantly available in the entire Western world. In the US, Canada, in Europe, South America, also in Asia and Africa. And with that, we can build a fully independent supply chain from raw materials through intermediate products to actual battery cells. But this is not just a play on resilience. This is also next generation technology. So these batteries are up to 3 times lighter than what's currently in the market and 40% cheaper at mass market scale, which allows us to actually build a technology that will enable the next generation of electric mobility. So think about electric airplanes flying throughout Europe, think about electric vehicles or electric trucking. And as I said, this is technology that's been under development for 1.5 decades now. We're now graduating from material science to actual industrial scale. And we now have our first prototypes, TRL5 prototypes, that we're actually testing in our own labs. So we can produce this at our own facilities, and we'll provide these batteries to customers within the next couple of weeks. We are starting out in the defense space for a very simple reason. Supply chains are a big problem in any kind of conflict, and if we're dependent on single nations, we have a big problem. And on top of that, you can imagine that a surveillance drone or an interceptor drone has a very different strategic advantage if I can enable it to fly 300 kilometers instead of 100 kilometers. So I can actually have an impact on the battlefield. We're already talking to customers to the tune of about 600,000 euros in prototyping agreements, and we'll be offering our first commercial product early next year. But that's just our beachhead market. We're also looking at drones in civil aviation. We're looking at micromobility for our early entry markets. We also have a couple of projects going in that direction. And then later on, we are moving to electric vehicles, electric aviation, space application, long-distance trucking. Basically, the entire battery value chain is open to us, which is a 650 billion euro market, of which the EU makes up 30%. The company was founded by my co-founder, Ida. She's our CTO. I'm the CEO, Aiko. We're now a team of 10 people with backgrounds in chemistry, electrochemistry, physics, computer science, engineering, some of them even at PhD level. We have our own facilities in Cologne, in Germany, and with lab facilities going really from, as I said, raw materials all the way to battery cells that we can produce in-house. The 1 million prize that comes with this is would be a great preparation for our seed round, which we will be raising next year. And it will allow us to significantly improve the development of our prototypes and actually get to further customers. So we're driving Europe's battery independence. Thank you very much. And I believe that we now have time for some questions, maybe.
Great. Thank you, Aiko. Who wants to start?
I can start. Thank you so much. I really feel that the future is already coming here. Perfect. A question about the protection. So is this IP protected, or does it need to be IP protected? And how do you really keep all the essentials in your company instead of like leaking it to China or wherever?
Absolutely, a great question. There are 3 patents associated with this belonging to the German Aerospace Center that we have an exclusive license to, that we're also negotiating a buyout option to. However, we've also already noticed that there are a lot of new developments that we can patent. And we're currently preparing IP protection for, I believe, at least 2, maybe even 4 patents next year. And there's a whole host of patent families that we can associate with this.
Hi, Aiko, there's a lot of verticals and modalities you want to tackle, from EVs to drones. How do you think through the prioritization trade-offs between different verticals as a result of this?
Pretty easy, pricing.
Okay.
So pricing is actually the boon. Current drone batteries are extremely expensive because they have a very specific load profile and are an underserved market. And also drones and micromobility, for instance, are comparatively small applications. So it's very easy to get into a first application with that, into a prototype, and scale up from there. Of course, mass market applications like EVs are everybody's holy grail. However, the margins are significantly slimmer, and it is more difficult to get in with those customers. We're already talking to automotive customers, but it's pretty clear that that's going to be like a 6 to 8 year development cycle until we actually get to scale. So that's interesting as sort of a long-term growth perspective where we want to get to. But those smaller markets with smaller applications with higher margins are actually much more interesting in the beginning.
What are the key steps taking this from a prototype to a marketable product that you're able to sell not only into defense, but then also into more commercial use cases as well?
Yeah, at this point, we have the chemical stack actually tied down pretty well. So the chemistry works like 95% where it should be. The rest of the 5% is like that's ongoing development, but we can already actually offer this to customers and have a benefit, show a benefit to them. The biggest issue now is scale up. So the two parts where battery companies typically die is chemistry and scaling that up. So we have the first one tied down. The second one we do through a stepwise iteration. So instead of saying, okay, we'll build the gigafactory first and go, for instance, to the automotive sector, we're looking to build a smaller facility, 10, 20 megawatt hours, scale that up again, and keep learning as we actually get into profitability pretty early on. In terms of what actually needs to happen for the on the battery production side, that is exactly where learning on smaller machinery enables us to then build the larger machinery without over-leveraging ourselves and actually in debt in that case.
Okay. There is time for a quick question.
Yeah, thanks. As an aeronautical engineer, this was really nice to hear. Where in Europe is the most of the raw materials you will be needing?
Yeah, so the only critical raw material that we have is lithium. Everything else, like the carbon structure that we produce, is from wet chemicals from the chemical industry. Sulfur is pretty abundant, so that's not an issue. There are massive lithium reserves that have just actually been found all over Europe. I think just a couple of weeks ago they found 43 million tons in eastern Germany. And also, we are already in discussions with partners in sea mining, so mining lithium from seawater together with seawater desalination.
All right.
Thank you.
Thanks a lot for the question. Thanks, Aiko.